In this unit, we examine a question a field geologist can answer standing in an open meadow, with no laboratory, no machine, and nothing in his pockets but a coin and a pocketknife. The question is this: how hard is this rock? It sounds like a question that ought to need an instrument. It does not. 2 centuries ago, a single elegant rule put every mineral on Earth in order of hardness, and you can carry that rule in your head. But the rule hides a trap in plain sight, right at the top of the ladder, and by the end of the unit, you will see exactly what it is. Part 1. The rock in the hand. Here we are fortunate to have a specimen, a perfectly ordinary rock, the sort you might turn up with the toe of your boot. We wish to know one thing about it: its hardness, not its weight, not its color, how well it resists being scratched. Now, in a laboratory, there are machines for this. But our geologist is standing in a meadow, and he has none of them. What he has is a problem that mineralogists faced for a very long time, and a beautifully simple answer worked out in the year 1812. Part 2. The man and his 10 minerals. The answer came from a German mineralogist named Friedrich Mohs, and his insight was to stop asking how hard a thing is on some absolute scale, and to ask only a comparison. Which of 2 minerals scratches the other? That is the whole idea. If the first stone leaves a scratch on the second, then the first is the harder of the 2. Scratching is a contest, and the harder mineral always wins. So Mohs lined up 10 common minerals as referees. At the bottom, the softest, talc, number 1, so soft you can mark it with a fingernail. At the top, the hardest thing he knew, diamond, number 10. And in between, 8 more, each one able to scratch everyone below it and none above. To place an unknown stone, you simply hold it against the ladder. It scratches the mineral at rank 5, but not the one at rank 6. Then its hardness sits between the 2. You have found its rung, and the loveliest part is that you rarely need the actual minerals. You already carry a small field laboratory. Your fingernail has a hardness of about 2.5, an ordinary copper coin about 3.5. A good steel blade about 5.5. So a stone your fingernail can scratch is very soft. A stone that blunts your steel knife and will not be marked by it is very hard indeed. A geologist reads a rock the way you might test fruit at the market, by hand and in seconds. Part 3. The scale that is not a ruler. Now we must be careful, because here is where almost everyone reads the scale wrong, and it is an honest mistake. When you see the numbers 1 through 10 laid out in an even row, you assume they behave like the marks on a ruler, that the step from 2 to 3 is the same size as the step from 9 to 10, that a 10 is twice as hard as a 5. It is not so. The Mohs scale is what we call ordinal. It tells you the order, who beats whom, and nothing about the distance between them. The rungs are ranks, not measurements, and the gap at the very top is the proof. On the scale, corundum is 9 and diamond is 10, next-door neighbours, 1 apart. But measured on an absolute scale of hardness, diamond is roughly 4 times as hard as corundum. That single step from 9 to 10 is a greater leap than all the steps beneath it combined. The numbers are ranks standing politely in a row. In truth, they are strangers. Part 4, hardness is not toughness, and now we come to the trap. The thing the whole unit was built to show you. It is worth holding still for. Diamond sits at the top, number 10. The hardest natural material on Earth. Nothing in the world can scratch it but another diamond. And from that, nearly everyone draws a reasonable conclusion. That a diamond must therefore be the most indestructible thing you could hold. It is not. A diamond can be shattered with a single well-aimed blow from an ordinary hammer. Here is the resolution, and it is the heart of the lesson. Hardness measures one thing and one thing only: resistance to scratching. It says nothing about resistance to breaking. That second property has its own name, toughness, and it is entirely separate. Diamond is supremely hard, and yet it is brittle. Its atoms are arranged in neat planes, and a sharp knock along one of those planes will split it clean in 2. The hardest thing on the scale has a built-in fault line. Part 5. The tough little underdog. To see just how separate the 2 properties are, we need only look further down the ladder, to jade. On the Mohs scale, jade is modest, around a 6 or 7, well beneath diamond. A steel file will scratch it. And yet jade is one of the toughest natural materials known. It is a dense felt of interlocking crystal fibers, and a blow that would cleave a diamond in half merely bounces off. Ancient peoples carved jade into axe heads and hammers for exactly this reason. It simply refuses to break. So here are 2 stones. One sits at the top of the hardness scale and can shatter in your hand. The other sits in the middle and can take a beating all day. This is not a contradiction. It is 2 different questions, and the scale only ever answered one of them. The gem cutter lives on this very difference. A diamond will scratch anything, which is why it is forever, and a diamond will cleave along its planes, which is precisely how the cutter shapes it. The same brittleness that can ruin the stone is the tool that reveals its fire. The review card. And so we have learned that a man in 1812 with nothing but 10 stones and 1 plain question put the entire mineral kingdom in order, and did it so well that a geologist can still read a rock with a fingernail and a coin. We learned that his ladder is a ranking, not a ruler, and that the quiet gap between 9 and 10 is wider than all the rest. And we learned the honest limit written into the whole scheme, that hardness is only resistance to a scratch, and that the hardest thing on earth can still be broken by a careless afternoon. Class dismissed, and if a small, exact order hidden inside something wild and ordinary is the kind of thing you enjoy, go and study the unit on how a snowflake's shape tells you the weather.